Okay, good evening, guys. I found this question when I was tutoring the grade, some grade 12. They were having problem with finding a and b. Okay, given a point and a tangent gradient. Okay, now the question is find a and b, or you can just say show that a and b is equals to a half, and a b and a b is equals to a 2. Okay, now you have a point, you have a gradient. What does that tell you about the graph? How do I find them? Now, first of all, let's firstly tackle the gradient part. Okay, you know, when the line is like this, the gradient will always be greater than 0. Okay, and then when the line is like this, the gradient will always be less than 0. Okay, that'll be your m. Okay, now when it's like this, it will always be 0. When it's horizontal, when it's vertical, it's always gonna be 0. Okay, now you have that. Now they say that they have given you a point. Okay, a tangent. What do you mean about a tangent? Now, a tangent is a line that touches a graph once. Okay, like this one, right? It touches a graph once. You see this line? You can see that it's also what? Vertical. That means it's a 0. Okay, that means here the tangent, the gradient, is equals to 0. Now, and then this one, it's increasing. Okay, it's increasing. That means the gradient is greater than 0. Now, what does that tell you? It tells you that the gradient and the derivative are the same. That means dy over the x at a certain point, when we say it's equals to 0, this is also equals to the gradient. Okay, that's what I'm saying. Okay, now let's go to the rough sketch. Not saying that the graph looks like this exactly, but this is just a rough sketch. Okay, a rough sketch whereby I only have a point and the intercept. I don't know where the turning point is. I don't know anything. I only know where the point is and the intercept. Okay, now the point is -1 and 7/2. Okay, and then the gradient right here, this line, as you can see, right, it's positive, which goes up to prove each and every that it's positive. What does that tell you? It tells you that that's where your dy over the x at that point is equals to a 3. Now let's go back into trying to attempt to answer our question. Now it says that show that a is a half and a b is a 2. Now you know how to find a turning point. To find a turning point, you need to find x, whereby you guys know the formula of -b over a 2a, and then y you just substitute it from the original formula. Okay, squared. Now this formula, where does this come from? Where does this formula come from? Now that formula comes from deriving using dy over the x. Deriving f of x is equals to ax squared plus bx plus a c. Now if I were to derive this, I'm going to say f derivative of f of x is equals to 2ax squared plus b. Okay, now I know, because this is a turning point, the derivative, the gradient, is equals to 0. So dy over the x, remember f derivative stands for dy over the x. Now this is equals to 0. Now 0 is equals to 2ax squared plus a b. Now if I were to solve for x, it's not a 2x squared, guys, sorry. When you derive, the 2 comes down, and then you subtract a 2 minus 1 gives you 1. So it's just 2ax plus a b. Now if I were to solve for x, I'm just going to be left with x is equals to minus b over 2a. Okay, now do you see where it comes from? Now we're going to use the same analogy to answer this question. We're going to start from deriving the first part. The derivative of f of x is equals to minus ax squared plus bx plus 6. Okay, and then I say, okay, fine, I'm gonna derive this and say that the derivative of f of x is equals to minus 2ax squared plus again with that 2x squared plus a b. Okay, now I set the gradient. Okay, if you are dealing with the turning point, we're gonna say the gradient is 0. Now I have a point of a tangent right here. I have a point of a tangent. Gradient is equals to a 3. Okay, and I said that the gradient is the same as the derivative. Okay, as the first derivative. Now if I were to say, okay, fine, this is equals to a 3, the gradient is equals to a 3 when minus 2ax, when x is equals to -1 plus a b. Okay, now, and then I put this in order. It's gonna be 3 is equals to 2a plus a b. Okay, and then I can just say, okay, fine, 3 minus 2a is equals to a b. I can call this equation number 1. Now immediately when you talk about equation number 1, when you start introducing equation, you must know that I'm gonna be dealing with simultaneous equation. So if you're not good with simultaneous equation, you will have a little bit problem. Okay, now we have this one. What about our second equation? Remember, what is the rule of finding a turning point? You find the x value, which is this one, which we have used the x value for this one, and then you need to substitute it from the real value, from the real function, from the normal function without the derivative. Now you see that f of x, okay, f of x, y, what is y at that point? Still speaking about at this point, we're only dealing with this at this point. What is that? It's gonna be 7 over a 2 is equals to minus a. What is x at this point? Minus 1 squared plus b minus 1 plus a 6. Okay, now 7 over a 2 is equals to minus a, because 1 negative 1 squared, anything squared is gonna be 1. 1 times negative a is gonna be negative a, minus b plus 6. So I can also rewrite this as 7 over 2 minus 6 is equals to, you take a 6 to the other side, minus a 6 is equals to minus a. What is b? What is b? Remember, b is our equation 1. Now this is where simultaneous comes in. You substitute this. You substitute this into this. You substitute 1 into 2. So we're gonna say minus, what is my b? 3 minus 2a. Okay, 3 minus 2a. Okay, now 7 over 2 minus a 6. Remember, 7 over 2, it's like saying how many times that's 2 goes to 7. 2 goes here, it goes here 3 times and a half. Okay, so it's gonna be 3, 5. It's 3 times, 5, right? Minus is equals to, now what is my a? I'm gonna say minus a, this times this one's gonna be minus a 3 plus 2a. Okay, 2a minus a, it's gonna give me a positive a, and then you take 3 to the other side, it's gonna be, you take 3 to the other side, it's gonna be 3, it's gonna be, take 3 to the other, it's gonna be 7 over a 2 minus 6 plus a 3. Now, okay, now you have a is equivalent to that. Now 7, like I said, is 3,5. It's 3,5 minus a 6 is gonna give me half, which is equals to, because 3 minus 6 plus a 3 is gonna give me minus 3 minus 3 minus 3.5 minus a 3 is gonna give me a half, so it's gonna be a half is equals to a. Now what do you do next? Now you go and substitute this from equation 1, okay, and you say, okay, fine, 3 minus 2 times 1 over 2 is equals to a b. This and this cancel out, you're left with 1. 3 minus a 1, it's gonna be a 2, which is equals to a b. Now see, you have shown that a is equals to 1 over 2 and then b is equals to a 2. Okay, and guys, the main thing you need to know is that every time when you're given something, always check. If you are given a tangent gradient, remember these steps. Okay, remember how your gradient stays. Remember that a gradient is the same as the derivative. Okay, now for the next question, I'm gonna take out the same question, however it's gonna be a cubic question. Okay, thank you for watching. Please hit the subscribe button if you like my work, and please comment. You can send in questions if you want to ask something or anything. Thank you.